let's continue our review for the Unit 1 lecture exam in astronomy by going over lesson number 4. So make sure and read your lesson objectives. Okay, this is going to be chapter 4 out of your textbook. Okay, so this particular lesson is going to have mathematics in it. So on the exam, I am going to give you all the formulas that you're going to need. What you have to be able to do is plug the numbers into the formulas. Remember that you also get to use a note card. So you get to use a 3-inch by 5-inch note card in which you can put anything that you want on the front or the back for it. Even if you don't think you're going to use the note card, make up a note card because it's going to help you to organize your thoughts when you take this exam. Alright, you got to know what speed is. So I'm going to use the words speed and velocity interchangeably in this course, but there actually is a difference between the speed of an object and the velocity of an object, but it's not that important for us. So we're going to use V for velocity, and the formula is going to be that the velocity or the speed of an object is the distance it travels divided by the amount of time it takes it to do it in. So the official metric unit for distance is the meter. The official metric unit for time is the second. So the official metric unit for velocity is meters per second. So think about your speedometer on your car. So it is in miles per hour or in kilometers per hour. So the kilometers is the distance that you travel. The hours is the amount of time it takes you to do that in. So here's an example of a mathematical problem. I could give you the distance and the time and ask you to calculate the speed. Or if I gave you the speed and the time, then you could put those numbers in here and then rearrange it using algebra to solve it for the letter R. So that's something that you ought to be able to do. Okay, then what is acceleration? Okay, now there are not going to be any questions on the exam where you have to calculate the acceleration of an object. But you do need to know what acceleration is. So what's the definition of acceleration? So A stands for acceleration, and it is the change, that's what the triangle means, in your speed over time. So when you accelerate, your speed changes. If you have no acceleration, then your acceleration is 0. So if your acceleration is 0, your speed doesn't change, and then you're moving at a constant speed. So think about what the accelerator of your car does. When you press on the accelerator, your speed changes. So an acceleration makes your speed change. The official metric unit, notice, is the meter per second squared. But there's not going to be any mathematics where you have to calculate what your new speed is if you know what your acceleration is. So just know the definition of what acceleration is. Okay, and then what is it that causes an acceleration? That's going to be a force. So you got to know that a force is going to be abbreviated by capital F. Its official metric unit is called the Newton, N. A force is a push or a pull. So if you pull on a rope, you're applying a force to it. If you push on a refrigerator, you're applying a force to it. So what are some types of forces? Well, we're going to be talking quite a bit about gravity, the force of gravity. So if I take this pen and I let it go, the force of gravity is what's pulling it down. There's also the force of electricity. There's also the nuclear force. There's also the strong nuclear and the weak nuclear forces. Later, when we talk about weather, we're going to talk about the Coriolis force. So all of these are things that cause pushes or pulls. So what can they do to objects? Okay, we just got through showing you that it pulls it down. So it can change the speed. So when it's in my hand, it has 0 meters per second speed. But as it's falling, it's accelerating. Its speed is getting faster and faster as it falls. When things bump into each other, they can change their direction because of a force. When you bend an object, you can change the shape of that object by applying a force to it. Okay, then what is mass? So mass is going to be given by the letter M. Its official metric unit is the kilogram. And mass is related to the amount of stuff that's inside of something. So the more massive an object is, the more atoms are inside of that object. Thing about mass is, another name for mass is called inertia. So an object that has a lot of mass has a lot of inertia. It's hard to get it moving, but once it is moving, it's really hard to stop it from moving. So that's another thing that is associated with mass, is its inertia. Okay, then Newton's 3 laws of motion. So his first law of motion is that an object that is moving will want to continue to move forever and ever at a constant speed in a straight line. Okay, the other thing is that an object that's not moving will want to continue not to move forever and ever unless a force acts on it. So that if you take an object and you put it on the table, okay, it's not moving, and it's going to continue not to move forever and ever unless you apply a force to it. So a force is a push. So when I push it, then all of a sudden it starts to move. An object, though, that is moving, so once an object is moving, it will move with a constant speed in a straight line unless you apply a force to it. And then you can either speed it up or you can slow it down. Okay, we said that forces cause objects to accelerate. And so that's given by this formula. Force equals ma. If you apply a force to a mass, that mass is going to accelerate. So here is an example of a kind of a word problem that you should be able to do on the exam. So that if you apply twice the force to an object, what will happen to its acceleration? What will its new acceleration be? And so you use the principle from algebra that if you do something to one side of an equation, you got to do the same thing to the other side of the equation. So 2 times the force will cause 2 times the acceleration. Okay, then Newton's 3rd law of motion. For every action, there's an equal and opposite reaction. So that if you push on your finger and you notice that your finger bends backwards when you push on it, do you notice that this finger over here does the same thing? So this finger is being bent the same amount that this finger over here is being bent. So if I apply a force on this finger, then this finger applies a force on this finger over here. And this is really important because this is how objects are able to move. So a wheel exerts a backwards force on the ground, but the ground exerts a forward force on the vehicle, and that's the reason why the vehicle will move in that direction. Same thing for a rocket. All right, let's take a break, and when we come back, we're going to talk about what is momentum.